think it was number
So it's
like number
22
20.
problems.
Yes.
Hey,
It's 22
everybody.
problems. What I
20,
would say,
20.
did I hear
Hello.
Keith?
That's me.
You better stop playing. Ooh. Uh, all right. Let me just continue the lesson. Hold on. So it is 22 problems, but I would say the GED high set tasks all cover up to about 18. Where you got binomials times trinomials, they're more difficult. You should be able to do them, but the GED only covers binomials times binomials, right? So which one did you have problems with? I'll make sure I do it.
Um, it was number 22. I believe that I was doing them and I got like really, really tired. So
Mhm.
like I started messing up because I did number 21, I believe, if it was right.
Well, it should have had the answers. You could
You
just
can
check
do
the answers.
22. We can,
All
yeah,
right.
right,
So
right. They did have the answer. So
this is
we
what
could
I would
work
say.
on
First of all,
22.
you got a trinomial because the first one in the first parentheses has 3 terms. The second one is a binomial that has 2 terms. For most intents and purposes, this type of problem will not be on your GED. So you might be asking, well, Mr. Tinsley, why did you give it to us then? Why? Is because you should be able to do before your level, at level, and above your level, right? Because if you can do the hardest types of problems, when you get to one that's less difficult, it should give you no problems. But let's do this one together. So first of all, we got 3 terms times 2 terms. That means you're going to have 6 terms when you're done. Okay, so what are we going to do first? What are we going to multiply first?
N squared to n squared.
N squared
I
times
mean,
2n.
2n.
Matter of fact,
Yes.
let me do red. I'm sorry. N squared times 2n. All right.
Mm-hmm.
So you multiply the coefficients first. So you don't see a 1 in front of this n squared, but it's a 1. 2 times 1 is what?
2.
2. And then what's n squared times n? Into the what?
Into the third.
Into the third. That's what most people make their mistake. And then then what are we going to do next?
Then
We're
you're
going
gonna
to
do
do n to the, what you say, into the square, into the
N
second
square,
You
N square
you were
times
trying to
4 times -4.
right. You trying to remember though. N squared
Yeah.
into the second power. Now what did you say? N squared, because that's what that 2 means, or into the
Right,
second
right.
power. So then we're gonna do that next. And what's n squared times -4?
N squared times -4.
Would it
a
be
-4n.
-4
-4, what?
plus 6n?
No. What? Well, you get plus 6 in. Remember
Oh,
what we're
I'm
doing?
sorry.
We're doing n squared times -4.
Okay, now we're going
4
to do
square.
-4
N
6.
n
N
squared.
square.
Yeah, okay. Thank you.
Now I'm gonna change my color. I'm gonna go to blue so we can see the difference. Now we're done with the n squared. We multiply n squared by everything in the second parentheses. Now we're gonna move to what?
6n.
6n times 2n.
6n times 2n. What's 6n times 2n?
12.
12.
12n
Squared.
12n
squared.
squared. If you notice, I lined it up because that's a
Mhm.
like term because they both have n squared. Everybody understand that?
Yes.
Now, what's my next step?
Negative, no, 6
N squared. 6n times. I mean
times
Negative
-4.
4.
4.
-6n times -4. What's 6n times -4?
-24.
-24 what?
N.
And squared.
-24n. Why'd you say n squared? Who said n squared?
Then, Mr. Tinsley, I was wrong.
Okay, so you want to make sure you take your time. Remember, n times n is n squared.
Mm-hmm.
We got 6n times -4 is -24n. So again, what you want to do is you want to process this the same way all the time. Do the
Okay.
coefficients first. 6 times -4 is -24. Then you take the variables that you have and you multiply them together. Well, you only got one n, so you just bring that down. It's nothing else for you to multiply it with. All right, what's the last? This time I'm gonna change the green. What's the last term I'm gonna be multiplying?
-4.
-4 times what?
2n.
-4 times 2n. What's -4 times 2n?
-8.
-8n. And then what's the last step? Multiplying what?
-4 times -4
times -4.
2. When you multiply two negatives, it makes it what?
Positive.
Positive 16. If you notice, I changed colors and I lined them up so you can see everything you need to do. So now we're going to bring down the 2n to the third. Now, because they are like terms, we need to combine the coefficients. What's 12 minus 4?
8
8 what? 8 what?
n squared.
8n squared. Okay, again, because we have like terms, -24 minus 8 is what?
-32
-32 what?
n.
N. And then we bring down to 16. Is there any other terms that we can combine?
No.
Nope.
No.
But originally, look how many terms we had. 2 red, 2 blue, 2 green. That's 6 altogether. Remember, this was a trinomial. We had 3. This is a binomial times 2. So we know when we start, we're going to have 6 different terms. But when we combine them, we end up with 4. So 2n to the third plus 8n squared minus 32n plus 16. So now what we do is we go check our work. Let me clear this out. We don't need any of this right now. And then we go check our work. This is what I want you to do for each problem. Number 23. That's why I always, for most intents and purposes, I try to give you the answers so you can check it. You don't have to wait. What happened to number 23? Oh, there you go, right there. 22 it was. 2n to the third plus 8n squared minus 32n plus 16. We are correct. Ding, 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 ding. That's how you do a problem. But again, let me explain something to you. The first, let me reduce my zoom here. So you should easily, or the ones you should be able to do up to like 18. You should be able to do 19, 20, 21, 22, 23. They hard, but you probably won't see them on exam. The ones you probably gonna see on exam are ones like 6, 5, 7, 8. How do I know? You look at the study guide. Study guide tells you I'm gonna have to know how to multiply binomials. Okay. So for me, when you have something like this, I'm trying to do this as least time possible. Right. So the first thing I notice is my multiple choice. 2 of them has 6x squared. 2 of them have 5x squared. So right away, 2x times 3x, I know my first term is 6x squared.
It's 6x squared.
So I know B and D are not even a possibility. Then I go to my last term. Minus y squared. I know it's not C. I'm done. Now, what they expect you to do is what we've been doing. 2x times 3x, 6x squared. 2x times y plus 2xy. minus y. If you notice, see how they try to confuse you there? They put the minus y. It doesn't matter. The rules are alphabetical order. So this is the same as minus 3xy. And then minus y squared. Combine like terms, 6x squared brings down. Combine like terms, you get minus xy minus y squared. Did we still get the same exact answer? Yes. So one thing you got to remember about multiple choice, usually two of the answers you can get rid of right away. Did I just see Carlos join us?
Minus X.
Yes, Mr. Stanley, how you doing?
Didn't you send me some science work, right?
Yes. Mm-hmm.
All right, I'll make sure I look at that tomorrow, okay?
Okay. Yep.
Everybody understand that? Now, let me show you something. But this is also another problem they might give you. Let me do it. They might say, let me do this problem real quick. I'm gonna make up a problem real quick. Hold on. Let's see. I think I'm right. I can't see what I'm writing. Hold on for a second. Okay, so say if I said this.
Mhm.
E is 2x plus 3. Oh, no, let me do this. Okay. So this is a quadratic equation. How do I know that this is a quadratic equation? Can somebody tell me? How do I know that this is a quadratic equation? You're going to see a problem like this. How do I know this is a quadratic equation? How do I know? Can anybody tell me?
The variables.
What do you mean the variables? Okay, so first we gotta know the difference between a linear equation and a quadratic equation. Okay, a linear equation, the highest power is 1. For a quadratic equation, the highest power is to the second power. So right away, what they're telling us to do is factor this quadratic equation. Okay, now I've already showed you that factoring this quadratic equation will take work. But instead of factoring this quadratic equation, we're going to use the answers and multiply the binomials. So with that practice sheet that I gave you last week, if you're able to do those 18, 20, 22 problems quickly and efficiently, and you know this concept, then this is a much easier way. So the first thing I'm going to do is my first term is 2x squared. My last term is minus 15. 2x times x, 2x times x, 2x times x, 2x times x. So all of them are going to have the first term 2x squared. Does everybody understand that?
Mhm.
Now, my last term, minus 3 plus 5, give me a minus 15. So I know A is still in the running. Minus 3 times minus 5 is not a minus 15, it's a what?
Positive 15.
So right away, I know it can't be B. Does everybody understand that? Now, 3 times minus 5 is minus 15. 5 times minus 3 is minus 15. So I can't use that shortcut that I just showed you. Why? Because the last term in all of these, first term is 2x squared, this last term is minus 15. So I got to do it all the way out. I'm going to change to blue. 2x times x is what?
2x squared.
2x squared. 2x times 5 is what?
It's 10.
10 what?
10x.
X.
10x. We got minus 3 times x. What's minus 3 times x?
Minus 3.
Minus
3x.
3 what?
3x.
Minus 3x. You cannot forget the variable. What's minus 3 times 5?
Minus 3J.
Minus 15.
15.
Minus
Oh, wait,
15.
you
Oh,
multiplying
That's
that.
1.
Do we have any like terms?
Hey,
Yes.
What are the two like terms?
10x.
10x and 3x.
So we're going to bring that 2x squared down. What's 10 minus 3?
7.
So
7x.
we got
7x.
7x minus 15. Is that what we're looking for?
No.
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 So
Not
we know
exactly.
it's not A. Let's do the third one. Now, we already know this. So 2x squared, 2x times minus 5 is not a positive 10x. It's a what?
Negative.
A negative.
Negative
10x.
10x. 3 times x is not a negative 3x. It's a what?
Positive 3x.
Positive
Positive
3x.
3x.
And then plus 3 minus 5 is minus 15. We have two like terms right there.
Mhm.
So we got 2x squared. What's minus 10 plus 3?
7.
Minus 7.
Minus 7.
7.
Minus 7x minus 15. Is that what we're looking for?
Yes.
Yes.
C is the answer.
Yes.
So instead of you trying to factor this quadratic equation, use the answers and use the skill that I just showed you, multiplying binomials, to do this problem also. So they're going to ask you explicitly to multiply binomials. They're going to ask you to factor a quadratic equation where they give you the multiple choice. That's two questions right there of one concept. Everybody understand that?
Mhm.
Now,
Yeah.
we have a person that took the exam. Am I right or wrong?
Yes, I had that on the test too. It was like 2 questions.
Exactly.
Yep.
So remember, we can't talk about what's exactly on the test, but we can talk about the concepts on the exam. So this concept, multiplying binomials, is important for you to know. That's at least 2 problems in your exam. All right, what else? What else do we need assistance with? So again, that's multiplying polynomials. Hold on, Mr. Tinsley, you said multiplying binomials. They just use the word polynomials to mean many. So that means you're going to have more than 3 terms when you're done. That's all it means. Got me? So for example, number 8 is multiplying 2 binomials. Number 4 is multiplying a monomial times a binomial. 1 times 2. Number 6, 2 terms times 2 terms. Binomials, because bi means 2. When you get down to the harder ones, this is a binomial times a trinomial. Just to make it easier, poly means many. That's why they use polynomials. Everybody understand that?
Mhm.
All right, good. Make sure you know how to multiply binomials. That's 2 questions on the exam. Just put money on it. Like you could, like, guarantee, right? Now, I got 3 emails this week about problems like this. So evidently, they must have put this back on the exam. Would anybody know how to do this problem? 3 over x plus x over x plus 2. Would anybody know how to do this problem? Like, huh? Like, you're probably looking at this like I have. How many people looking at this like I have no idea?
Me?
Me? Would
Remember
you?
what? Remember what I told you. Start with what you know. Start with what you know.
Is it just
So,
like the ones that we just did? That you don't put them in order like that?
it's you're gonna use part of what we just did, but it's some conceptual understanding you need first, right? So for example, let me ask you a question. If I wanted to add 1/3 plus 1/5, would I go, oh, that's 2/8? Is that how I do that problem?
No.
No.
No, that's not how I do it. What I'm gonna do is I need to find a common denominator, right? So I'm gonna multiply this side by 5/5. Let me write it right. And I'm gonna multiply this side by 3/3. Because in order to add and subtract fractions, you must have a common denominator. Does everybody understand that? So what I did was I multiplied the first term
No.
by the other denominator, top and bottom. Everybody understand that?
The
Now,
first term by
why did I do top and bottom? Because what's 5/5 equal to?
1.
1.
One.
What's 1 times anything is itself.
Right.
So I'm not changing it. Same thing, 3/3. So now you get 5/15 plus 3/15. And now since they have a common denominator, I add the tops and keep the denominator. So this 8/15. So everybody knows how to do that. Am I correct?
Mhm.
Okay, perfect. That's adding fractions with unlike denominators. But Mr. Tinsley, they got x and x plus 2. Again, start with what you know. You know to add fractions, you must have a like denominator. So what I'm going to do is, let me make this a little bigger so everybody can see it nice and clearly. What you must do is say, hold on. You cannot get flustered on this exam. Go back to what you know. These are 2 fractions being added. That means I must have a common denominator. That means I'm going to multiply this side by x plus 2 over x plus 2. I'm going to multiply this side by x over x. Everybody understand that?
Mhm.
Okay. So now, when I look at the top, I'm multiplying 3 times x plus 2 over x times x plus 2. Mr. Tinsley, that says x plus 2 times x. Remember, okay, you got to understand your properties, right? It doesn't matter what uh, um um how you multiply. You can multiply in any order. 3 times 4 is 4 times 3. So I just changed 3 times x plus 2, x times x plus 2. Everybody understand that?
Mhm.
Plus x times x over x times x plus 2. Do they now have the same denominator?
Yes.
Yes. So now I distribute. This is the property that we used. We just learned, or just used, not just learned. So I got to multiply that 3 by everything inside the parentheses. So I get 3x plus 6 plus, what's x times x?
1.
1.
1.
You said x times
Correct.
x.
That,
Correct.
that's what we just did over and over again. What is x times x?
1x. X. What is it?
X squared.
X
Square.
squared.
Mhm.
That's what I'm talking about.
That
You
is
can't, you
muted.
cannot
X
think
squared.
x times x is 1.
It's x squared.
It's x squared.
You don't even see
This is why you practice. You say it, you do it, you write it, you see it. X times x is x squared. 2x times x is 2x squared. When you see x times x, it's going to the second power. On the bottom, we have x times x plus 2. Now, just going to change the order because this is what we do. This is what we notice. Highest degree first. X squared plus 3x plus 6. All I did was change the order. I put this first, put this second, put this third. Because algebra says highest degree, then go to your variables, right?
Mhm.
So then we have x over x plus 2, right? Now, so let's say that. Let's look at our answers. Here's our answer right there. So a problem that looks like this is considered a difficult problem. So you might be saying to yourself, Mr. Tinsley, I don't know how to do that problem. That means you're going to watch this video 2-3 times till you got it.
Yeah, I'm gonna have to.
Yeah, me too.
First thing you got to look at, they don't have the same denominator. Second step, multiply the other term by the denominator, top and bottom. Doesn't matter what problem you get. But what happens is this comes from doing something like this. 2/3 plus 3/5. So I'm multiplying this side by 5/5. I'm multiplying this side by 3/3. So what you notice is this denominator is top and bottom over here. This denominator is top and bottom over here. So you get 10/15 plus 9/15. 19/15, which is 1 and 4/15. But that's computation. That's using numbers. That's using fractions. This is using variables. It's the same process. Everybody understand that?
19 from over 15, Mr. Tinsley.
So 15 going to 19 one time. How many do you have left over? 4,
Yeah.
same denominator.
Yes. Yes, I
Now,
see.
that's another problem that's probably guaranteed in your example. I mean, on your exam. Turning an improper fraction to a mixed number and turning a mixed number to an improper fraction. That's one of your first 5. Gotta know it. How to turn an improper fraction to a mixed number and how to change a mixed number to an improper fraction. It's almost guaranteed first 5 on your exam. So all of these concepts has multiple things. You just got to be ready. You got to practice enough. So you got to practice enough till you know it. All right, what's next? So this is a question that came in my email. 2 or 3 people sent me problems similar to this one, where they had to simplify or add algebraic expressions with unlike denominators. Multiply each term by the denominator of the other term, top and bottom. Got me?
Multiply each term by the denominator, top and bottom.
So, for example, let me do this one more time. The denominator here is x. The denominator here is x plus 2. So, I'm going to multiply x plus 2 over x plus 2 times my first term, which is 3/x.
Mhm.
Okay, my second term is x over x. So, x over x times x over x plus 2. Okay, I'm going to rearrange it so it makes sense, or how I'm used to seeing it. So I'm going to put my 3 first, multiply by my x plus 2. I'm going to put my x first times x plus 2 plus x times x. I'm going to put my x first. My x is first over here. X times x plus 2. Do they now have the same denominator? Yes, they do. My denominator for both terms is x times x plus 2. Now, you distribute that 3. 3 times x is 3x. 3 times plus 2 is a plus 6 over x times x plus 2. X times x is x squared over x times x plus 2. Oh, they have the same denominator. So now all I need to do is add the numerators. There's no like terms in the numerator. So we just need to put them in order. X squared plus 3x plus 6 over x times x plus 2. This is considered a difficult problem. So I can tell you right now, What I would tell you is make sure you know how to do a problem like this. But if it's considered a difficult problem, if this is considered a difficult problem and you're having problems understanding how to do this problem, what are you going to do when you get this problem on your exam?
Skip it.
And flag it for review. Come back to it when you what?
Finish.
When you finish the exam.
Mhm.
Listen, doing 5 hard problems in a row don't make sense. Doing 5 easy and medium questions in a row makes sense. Why? Because then you build your self-esteem, you build your confidence. Then as you build your confidence, you come back to a problem like this, you say, I remember what Mr. Tinsley told me. Those rational expressions have 2 unlike denominators. I got to make sure they're the same. Oh, that's right. I got to multiply by the other denominator, both top and bottom. So as you're doing this problem, as you're watching this video, you say what you're doing out loud. So when you say x times x, you're not saying 2x. You're saying x times x is x squared. Oh, 3 times x plus 2, 3x plus 6. Say it out loud, write it, do it. Got me?
Mhm.
All right. What other concept have we been working on? I've been trying to find this other problem that I got an email and I can't seem to find it. What else have we been working on this week that you want to go over? It could be on my website. It could be from any book you're using. It could be from anywhere. It doesn't matter.
I just wanted to go, like the polynomials out. That's what I was working on, that sheet.
Okay.
Mhm.
So similar to that is something like this. What does it say? Creating polynomials from written descriptions. So this question says, a rental company carries tables that seat 2, 4, or 8 people. For a wedding, a customer orders X tables to seat 2 people, Y tables that seat 4 people, and Z tables that seat 8 people. Which expression represents the number of people who could be seated at the tables that the customer orders? What are they talking about? Y, Z, A, B, G? No,
That's the second one.
you're not getting yourself flustered. If you don't know, right? Put numbers there. I got 2 tables with 2 people,
Right.
right?
Mhm.
How many people do I got?
4.
4. If I got 3 tables with 2 people, how many people do I have?
6.
6.
What operation, if this is 3 tables with that seat 2 people, what operation is that?
Multiplication.
Multiplication. So how do I write 2 times x?
X squared.
Stop
Yeah,
playing.
2.
And
How
in
do I write 2
parentheses,
times x?
2x.
2.
2x.
Oh,
2x.
2x. I'm sorry.
Listen, that ain't hard to do. Multiplication right next to each other.
Yes.
So that means now that I understand that I'm multiplying to get each expression, if I got y tables that seat 4 people, how am I writing that?
Um,
Thinking too hard. If
the
x tables
4y,
that seat 2 people,
4,
4y.
Mhm.
4y.
If I
Yeah.
need z tables that sit 8 people, how am I writing that expression?
8z,
8z.
8z. What am I going to do to all these numbers? So now, again, use common sense. So say, for example, I had 6 people here, 8 people here, 16 people here. How many people would I have all together? What would I do? What operation would I do?
We'll add them.
the
You
You
first,
add
add
them.
'em.
So
yeah.
2x plus
32.
4y plus az.
So I said 2.
You were right. But how many people get this problem wrong?
Hmm.
You should see how many people get this problem wrong or incorrect. It's an easy problem. But what happens is when you start seeing all these variables and all these numbers, your head start getting scrambled. Use common sense. Put numbers there and see what operation I'm going to use first. So that's why I drew a diagram. And I said, oh, if I got 3 tables that sit 2. That's 6. That's multiplication. Oh, that's 2z. So 2z, 4y, 8z. So I now know what to do to get the number of people that sit at each table. That's easy. But what do I need to do to all those numbers? I need to add them.
Add them up.
You should see, you should, excuse
Can
me,
you do
you
some
should
more
see
word
how many
problems?
people get this problem incorrect. I literally just marked 3 practice exams or 3 study guides. And people did these study guides. It was from Virginia, one was from Maine, and the other one was Florida. They all got it wrong. Most people, all 2 of them picked this one, and one of them picked this one. I don't even know how they picked the 3rd one. Like, I don't even see how that even makes sense. But it's okay, because we all can make mistakes. What happens is, don't get flustered when you see all these numbers and variables. Read it carefully, draw diagrams if you need to, put numbers in there if you need to, because that'll tell you what operation you need to use. Everybody understand that?
Yes.
What's next? Tell me something else we've been working on. Tell me something else that we've been working on. Doesn't
Some
matter if
more
it's a
word
practice test.
problems.
Some more word problems. That's
Yeah.
that's a
With
general statement.
linear equations.
Linear, I love it. I love it. Let me find a problem. Let me find. So I'm gonna go to my website. I'm gonna go to my website because I got a whole bunch of linear equations with word problems. Let's find one right here. So let me put this on the screen so you see. And this is what I mean by, listen, if you need help, I got help for you. I got it for you. Now this is CK12, but these ones I made by myself. Look at this. Comparing different sources. Linear equations, what does that say? Word problems. Linear equations, word problems, 2. Linear equations, word problem, 3. When I'm telling you, you don't need to go anywhere else. You got it all right here. The level of difficulty is up. Just depends on how much time you're going to put in. The more time you get in, guess what? CK12, my assessments, they get harder. But as your understanding gets better and better, these problems should be a little easier. Now I'm not going to go to actually the quiz. I'm going to go to edit the questions, and let's look at it. And you tell me how you decipher these questions. I want you to tell me. Let's look at this one right here. Make it bigger here. Now for these, this is much harder than you're going to get on your GED because I asked actually 3 questions. This first question. But the reason why I do that, why is it not getting bigger? There we go. Ooh, not that. Ooh, there we go. I don't even know how I did that, but I wish I knew how to do that because now I can make every question bigger. I got to figure out how I did that. A machine salesperson earns a base salary of $40,000 plus a commission of $300 for every machine he sells. Write an equation that shows the total amount of income the salesperson earns if he sells X machines in a year. Write linear equations in slope intercept form, y equal mx plus b. What? How am I gonna figure that out, Mr. Tensley? No, that's not what you're thinking. Identify what you know and start there. Okay? How are we gonna start this? Because this problem probably just blew the top of your brains off just now. I heard it. I could smell the brains frying right through the microphone. I can smell it. Because you're sitting there
And we
saying,
do know
you're
we do
sitting there
know that
saying,
Base
I'm
forty
not.
thousand
salary,
dollars
you
is
know the
not
base
going to change.
salary.
That's the
What?
base.
Say that again.
We know the base
$40,000
salary
is not going to change. That's the base salary.
Stop playing.
Um,
So
and the
now,
commission
so
for
hold
every
on,
machine.
hold. So if we know that the equation must be y mx plus b, and this is not going to change, is that the m or is that the b?
that's the B.
That's
Okay, so Anna said it's b. How many? Give me some more. Give me some more feedback. Is it m or is it b?
is M.
Yeah.
Okay, I heard it's m. I heard that was from John Dell. Anybody else?
I said M.
Say
Linnell, that's B.
I,
That's
s-
3. Anybody else?
I said M.
So so
So
3
it
people
can't
said
be
M.
Y.
Cause
So,
it's not going to.
what did Anna say that was important? What she said was,
The base
your
is not going
40,000 is
nowhere.
not going to change no matter how many machines you sell because that's your base salary.
That's your salary.
What do we
So
know
that's the
about this
base.
term? So, for example, if I got y equal 2x plus 3, if my x is 1, I got 2 times 1 plus 3. If my x is 2, I get 2 times 2 plus 3. If my x is 3, I get 2 times 3 plus 3. What is not changing?
The 2.
Right, well, that's the 2 not changing, but what's not changing? This
The
The
3.
slope.
Yeah, 2
The
times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Yes, the 2 is not changing because that's what we're multiplying by. But when we simplify it, that term is changing because this term here is variable.
variable.
But what gives you the clue is because the term contains a variable.
Yep.
This term right here is B. It's not going to change. This is constant. So right away, when Anna said, what's key what she said is, no matter how many machines you sell, you're making a base salary of 40,000. You know your equation is going to be y equal mx plus 40,000 because
Okay.
that's your B.
Okay.
Let me clear this real quick. We said this. We said y equal mx plus b. This is my B. Now, this is the key. What's my M? What's my M? What's my slope? See, you might didn't even think of it this way. But how do you know to think of it this way? Because they gave you a clue right here and said it must be in this form. And we know M stands for slope. We know B stands for the y-intercept.
Mm-hmm.
So they're only giving you two numbers here. So if we know 40,000
It's the Y-intercept.
Gotta be the
is the
300.
y-intercept,
Yeah.
it got to be the 300. But this is
300.
how you know, just in case they throw other numbers in there. If I sell one, how am I going to do that calculation? 300 times 1 if I sell one machine. If I sell 2 machines, it's going to be 300 times 2.
Mhm.
This number right here is variable. That's going to change.
Mm-hmm.
So your equation is y equal 300x plus 40,000. So when you look at a word problem and they're asking for a linear equation, the first thing you were thinking is what's not going to change? What is going to change? That $300 depends on every machine.
Mm-hmm.
So right away, I know that's going to change because I don't know how many he sold. If he sold 0, my x is 0. If I sold 1, my x is 1. Everybody understand that?
Yes.
Mm-hmm.
So my equation is y equal. Matter of fact, let me save this right here. Let me erase all this other stuff up here. Let me change my color to blue. Why I choose blue, but I just want to. That's my linear equation. What is my linear equation represented above? Y equals 300x plus 40,000. So now, the second part of this. Now, again, if you understand these problems, you can almost answer any word problem that has to do a linear equation on the GED. Because you're going to get 3 to 4 of these. So, what would be the salesperson income if he sold 150 machines? So, the key, what do I know? What's my variable X stand for?
X machine.
What does my variable X stand for? The what?
The number of machines.
The number of machines. So what this is telling me is X is equal to 150. So now you're grabbing your calculator because I already showed you how to evaluate an algebraic expression and how to use the calculator. I said, oh, 150 store X, enter. What's my linear equation? 300x plus 40,000. How much would he make if he sold 300 machines? 85,000. All these concepts are related, but you got to walk, talk, write, see it down. You got to have a conceptual understanding, and you got to walk yourself through each step. You got to keep using the terminology. If I told you right in this form, y equals mx plus b, your first instinct was m is my slope, b is my y-intercept. My term mx is going to be changing because it contains my variable. B is a constant. It's not going to change. It's the first thing you should be asking yourself. So this answer was 85,000. But the second part of this, Mr. Tinsey, why do you got 3 different parts on one equation? Because I want you to be prepared no matter what they ask you. How many machines would the salesperson need to sell to earn $100,000 income? So how many machines? We know machines is what variable?
X.
So they're asking you to solve for X. If they're asking you to solve for X, they're giving you what? What's the $100,000? What variable is $100,000?
The B.
What?
MX.
Will be
It's
X.
the B. It's not the B?
No.
Write this formula down for you. Y equal 300x plus 40,000. How many variables do we have in this equation?
1.
1? How many variables do you see in this equation?
We have
have
2.
2.
We have 2. What are the 2 variables? What and what?
Y and X.
Y and X.
X and Y.
X and
They're
Y.
asking you to solve for X.
Yeah.
So this
I
must
will
be what?
Y.
Y.
Mhm.
So
That's
I'm going
what I
to
was
replace
saying.
Y. I'm running out of room here, so I'm going to come up here. 100,000 instead of Y equal 300x plus 40,000. Now, I'm going to rewrite this on a blank page because I need you. I don't want, see, it looks messy. It looks confusing. So let me go to a blank sheet. Let me go to my here, blank sheet. And I'm going to take all this, I'm going to erase it. Because I 300x plus 40,000. So y equal 300x plus 40,000. What you have to understand is terminology. This is my linear equation. I have 2 variables. This is a linear equation given 2 variables. The question is, how many machines must I sell to make 100,000? I know X stands for my number of machines. I now see Y is the amount I'm going to make, my total. Identifying what you know. So now, if I know Y is 100,000 equal 300x plus 40,000, this now becomes a 2-step algebraic equation. What am I going to do first to solve for X? What am I going to do first? 100,000 equal 300x plus 40,000. What term do I need to get rid of first? Solve for X.
Wait. Equals 40,000.
1, 2, 3, 4, 5, 6, 7 people on here. And you telling me 100,000, 40 what? It's not 40. 40,000. I need to get rid of 40,000. What's the opposite of plus 40,000?
Subtract it.
Subtract. Now, see what I mean? It's taking you 30, 45 seconds to process this. That means you have to work with algebraic equations. So this is not an issue. Right away, you should be saying, oh, I'm trying to solve for X. X is on my right side. I got 2 terms on my right side. I got to get rid of one of them. If my X is in one of the terms, I can't get rid of that term because then my X is gone. So I got to get rid of that 40,000. The opposite of plus 40,000 is minus 40,000. What's my next step?
Do it on
Whatever
the
I
other
do on
side.
one side, I
I
do on the other. What's 100,000 minus 40,000?
60,000.
60,000. I bring down my equal. I bring down my 300x. Is x still by itself?
No.
No. What can I do to get x by itself? Right now, it's being multiplied by 300. What can I?
Divide it.
Why did you
Divided
say
by
divide? Because the opposite of multiplication is what?
Division.
Division. So I divide by 300. What's my next step?
divide by 300 on the
Divide by 300. What I'm going to do is, since I got 2 zeros at the end here, let me change my color to red. Since I got 2 zeros here, I'm going to get rid of those 2 zeros. Since I got 2 zeros here, I can get rid of those. I can get rid of this 300. This becomes 600 divided by 3 is equal to x. I don't need the calculator for that. I know I have the same number of zeros in both those numbers. That means I can get rid of them. That's what I mean when I took in that quiz, the powers of 10. You got to know that the number, if I got zeros at the bottom, I got 2 zeros at the bottom, I got 2 zeros at the top at the end of that, I just get rid of them. 600 divided by 3. Now I should be able to do that in my head, which is what?
200.
200. So how many machines must I sell to make 100,000?
200.
That's it. That's real life. People who sell cars, that's real life. People sell appliances, that's real life. What do I need to sell? Because I work on commission to make this amount of money. My goal is to get to 200 these machines so I'll make $100,000 this year. That's real life. But again, this problem, will you see a problem this difficult? No. But you might see A, you might see B, you might see C. So what I did was in one problem, gave you 3. Because if you can answer every question they possibly can ask you, that means you're going to be ready whatever one they give you. Let's look at this one right here. Lynn is tracking the progress of her plant's growth. Today, the plant is 5 centimeters high. The plant grows 1.5 centimeters per day. Write a what type of equation? A linear equation in slope-intercept form that represents the height of the plant after D days. So what is a linear equation in slope-intercept form? What is that equation?
Y equals mx plus b.
Plus B.
But the problem is they're saying use H
Height.
and D.
Mhm.
So now instead of Y equal mx plus
Y.
B, it's H equal, right?
MX.
Mhm.
M, not MX, M what?
MD.
Plus B.
Plus b.
Now, to me, I wouldn't even tell you to do that. I would say, listen, don't even confuse yourself. Just use Y equal mx plus B. You'll be able to figure it out. What's not changing and what's going to change day after day.
The
So
height.
so what's M? So you got 2 numbers here. Today the plant is 5 centimeters high. The plant grows 1.5 centimeters per day. What is changing and what numbers not going to change?
1.5 is mx
It's not
and
going to
5
change.
centimeter is the b.
So what? I'm sorry.
1.5 is mx
So that's
and
my M.
mhm,
Mhm.
and the 5 is b.
Okay, perfect. So now when I rewrite this equation, y equal 1.5x plus
B.
5.
Oh, plus 5.
Because you said, because Anna
Right,
just
it
said
grows
my B is 5, my M is 1.5. Well, the key word, how you know it's going to change is what?
per
Per
day.
day.
It's changing per day. 1.5 today, 3 tomorrow, 4.5, 6, right?
Mm-hmm.
That's easy. But now, look what I did. I didn't change. I didn't use the variables H and D. I still got my linear equation, right? Now, that is the equation, but they want you to use H and D. So now it's H equal 1.5 times D plus 5. That would be using H and D. They're the same equations, but instead of using X and Y, we use D and H. But the key is, look at that, 1.5 centimeters per day, 1.5 D. You can't get wrapped up in these variables. It don't matter.
Mhm.
Now, what will be the height of the plant in centimeters after 20 days? Is that H or D? What is this? What number is this? Is that going to be H or D?
Is
D.
the
It's D. How do you know it's D? It's telling you right there.
oh shit.
It's A.
The
It's
days.
telling you 20 days. Your height can't be 20 days.
Mhm.
So H equal 1.5 times 20 plus 5. So H equal 20 and 10, that's 30 plus 5. Again, I did that in my head. Mental math. You don't have to rely on your calculator. 20 times 1 is 20. 0.5 is a half. What's half of 20? 10. 20 plus 10 is 30 plus 5. Your height after 20 days is going to be 35 centimeters. A hard problem with two different questions become easy when you can identify what M is and what B is. That's any linear equation. Let's try one more because it's 7 o'clock. One more. Oh, I like this one. This is lovely. But this is, yeah, I'm gonna stay with that one. Yeah, I'll stay with that one. This is lovely. Mr. Thompson is on a diet. He currently weighs 260 pounds. He loses 4 pounds per month. Write a linear model, linear equation that represents Mr. Thompson's weight after M months. That's what confuses people. Why are you asking me what M months? I don't know. Identify what you know. First of all, what do we know from the paragraph?
That he weighed 260 pounds.
Currently weighs 260 pounds. What else do we know?
He loses 4 pounds a month.
He
4
loses
pounds per
4
month.
pounds per month. What is my M? What is my B?
Your B is
Is the B
260
the
pounds.
260?
My
Yeah.
B is my 260. What's
And
my
the-
M?
The 4 pounds?
Or
Key is loses 4 pounds. So my M is not going to be 4. It's going to be what?
-4.
-4. So my equation is Y equal minus -4x plus 260. I identified what's going to change. I'm losing 4 pounds, so that's why I got the -4. Because I'm losing 4 pounds per month. I'm subtracting away -4. My B is what I started with. That's my initial weight. That's not going to change. 260. Everybody understand that?
Yes.
That's my linear equation right there. So after this, write a linear model that represents after M months. The only thing that is M. So let me ask you a question. So M months. So instead of X, right, 4 pounds per month, it's telling you what the variable is. M stands for months. So Y equal -4M plus 260. They didn't tell you anything about Y. Keep Y the same. Now, I probably would have changed Y to W. So weight equal -4 pounds per each month plus my original weight is 260. That make more sense. But it doesn't matter. You can start with the original Y equal MX plus B, then change the variables when necessary. Now, after how many months will Mr. Thompson reach his goal weight of 220 pounds? Is my Y 220 or is my M 220?
Is it the wait, because you say that this don't change.
That doesn't matter. You thinking
No,
about
I'm
something
trying
you
to
don't need to. What does M stand for?
M is the negative pounds, the months.
The months.
The months.
The months. So 220 pounds can't be your M.
Nope.
M
So
is
it's
the
the
number of
Y.
months.
The
The
Y.
Y. So
Mhm.
now I'm gonna change my color. 220 equal minus 4M plus 260.
Mhm.
Okay. In order to get M by itself, what must I get rid of first?
260
And what's the opposite of plus 260?
minus
Minus 260. Whatever I do on one side,
You're doing the
I do on the other. What's minus 260 plus 220?
You said minus 260 plus 480.
Nope.
You said minus
Minus 260 plus 220.
a negative
40.
480.
Negative 40.
out of 4.
Negative
Again.
said plus.
Again, yes, that's what I said.
Hey, I'm looking at go. I see it now. I'm gonna stop answering questions. I see it.
No, 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 no. You cannot stop answering questions because the minute you stop answering questions, if you make a mistake, you can't learn from your mistake. If you just sit back there and say, "Yeah, I understand." No, the purpose of this process is for you to answer it. If you get it wrong, you got to see your mistake. You got to say, "Oh, sign numbers. They got two different signs. I need to take the difference between the two numbers. 260 minus 220. 260 minus 220 is 40. And take the sign of the largest number. 260 is largest, so minus 40. Or plug it into your calculator, 220 minus 260. Either way, you got to know that's minus 40. I heard 480. I heard minus 480, right? It's minus 40 equal minus
Because
4M.
I was looking, I was listening to you, but not looking at the signs on the opposite side. That's why I kept seeing the 480.
No problem. So this is why, like all these concepts, when you're making mistakes, it's better to make a mistake, then you know where you made the mistake so you can fix it. I'd rather you answer a question and get it wrong and then figure out why you got it wrong and then do the problem again and get it right. But if you just sit here and say, "Oh yeah, I understand," what happens when you go home and go do this problem all by yourself? Oh my God, what's Mr. Tizzy talking about? I can't remember. That's what's going to happen. I'm telling you, I know. I've been doing this for a long time. So as you're doing each problem, you walk yourself through the steps. If to reach his goal of 220 pounds, well, that can't be M because M stands for the number of months. So it must be my Y. Okay, so now minus 40 equal minus 4M. M is not by itself. How do I get M by itself? What do I need to get rid of?
Need to divide the 4M.
Not 4.
Negative 4M. I'm sorry.
Negative 4. So to get M by itself, I got to divide by negative 4.
Negative 4.
Whatever I do to one side,
You do it to the other.
I do the other. Two negatives make a what?
Positive.
So I'm going to write it over here. I'm running out of space. 10 plus 40 divided by 4 is 10 equal. The two negative 4's cancel. I'm left with M. How many months to reach his goal to get to 220 pounds? How many months?
10 months.
That's your answer. Or, watch this. I'm going to show you an even better way. 260 minus 4, 256, 252, 248, right? Right?
No, you get me confused, man.
240, 236, 232, 228, 224, 220. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I do any algebra?
No.
I used common sense. I started at 260. If I'm losing 4 pounds a month, I take away 4, 256. I take away 4. I keep taking away 4 till I get down to what?
220.
Then I count how many months.
Mm-hmm.
I used not 1 ounce algebra. I used common sense. I started at 260. I'm losing 4 pounds a month. Let me just subtract 4 until I get down to 220. How many times do I have to do that? 10. I got my answer. That's
Oh.
no algebra. Did I use an ounce of algebra?
Nope.
Remember, again, y equals x plus b. Whatever is my m is I'm going to be doing that over and over. So here, I'm losing minus 4 pounds. I'm doing that over and over. I'm taking away 4. I'm taking away 4. I'm taking away 4. When I get to 220, I know to stop. I count how many times I did that. 10 times. Got my answer. No algebra. That may be easier for some people to think of instead of doing all this linear equation stuff. But I guarantee you, you're going to see a problem like this. They're going to say, oh, you got a budget of $1,000 and a hat costs $8. How many, and shipping is $20. How many hats can you buy? They're going to, listen to what I'm telling you. You're going to have problems just like this. 3 to 4, maybe 5, maybe 6. Listen, when I'm telling you linear equations is anywhere from 4 to 10 problems on the exam, you better be ready. Better be ready. You will see it. I guarantee you. Let me pause.